Hello, my name is David and I'm going to show you an overview of the system I've devised for exercising electromechanical aircraft instruments. This is a microprocessor based solution using a combination of Raspberry Pi Pico and ESP32 with display module and expansion modules. I call it Aviation Integrants. In addition to the microprocessors, there are several additional boards which perform the interface between the software and the actual instruments. These boards are connected together using a simple backplane and share a bus distributing control and power signals between the modules. Aviation instruments typically use 400 Hz AC power at either 115 or 26 volts. Additional DC power at 26 volts is also sometimes required. A few instruments, typically those with gyroscope motors, require three-phase AC power at 115 volts, 400 Hz. The system grew out of a desire to control the servo motors found in aviation instruments by simulating the control sources used to drive the instruments in real use. This task requires creating variable phase and amplitude 400 Hz signals at around 12 volts AC. It has been expanded to include other signals to drive a variety of inputs and outputs found on the instruments I own. The main user interface is a menuing system using an LCD panel together with a rotary encoder and some buttons. The system revolves around the ability to join inputs to outputs in an arbitrary way. Menu options select which input is connected to each output. The selection is stored in EEPROM between sessions. The system is network enabled. The menu can be driven from a PC via Wi-Fi and its output data is sent and received using MQTT protocol, allowing switches and gauges to be made using third-party programs like Node-RED, for example. Almost every aircraft instrument will need some source of 400 Hz power. Often not much power and single phase is all that is required. I have had success using surplus inverters to drive small instruments. Bigger instruments need more power. The moving map uses more than 1 amp at 115 volts, 400 Hz, and for this I have used a vintage rotary converter or mains-powered industrial 400 Hz supply. The DC supply I'm using is a mains transformer, bridge rectifier and smoothing capacitor feeding into a small switching buck-boost regulator set to 26 volts. This can drive an inverter and power the logic boards through a 5 volt regulator. Now I shall show you how I configure a synchro transmitter simulation whose position angle is set by the rotary encoder. In this example, the output is connected to the synchro receiver input of an aircraft pressure gauge. Well, that's all for now. Next time I'll show you how the individual boards work in some more detail and what the system is capable of doing. Thanks for watching. Goodbye.